In this session, we'll run a downstream throughput test. So we ran throughput before. Remember, ports and clients are already set up. And we had run ourselves an upstream throughput test before and found that the access point performed very close to theoretical max. Now remember, we had done a couple of shortcuts, like setting the trial duration to 5 seconds. We may see different results if we change this up to the 30 seconds that it ought to be, but that's okay. Well, this is just for teaching you how the application works. So in this case, we're going to run the throughput property, same 15, 18 byte frames, same search maximum, all those things, and all we're going to do is go Ethernet to wireless. Okay, so the test starts up, does exactly what we were expecting it to do, checked the firmware version, connect up the clients, ARP through. But now we're going to watch what happens in the downstream direction. So it's going to run 50% for 5 seconds, and there was 0 loss. That's good. It's kind of what we would expect. So now that binary search algorithm goes to work, and we're going to 100%. It passed that, so again, now we go to 125%. Now we notice that we achieved 79,000 packets, and theoretical 79,000 packets a second. When we went to 125%, notice that we were attempting, it achieved 86,000 packets per second. Now it's 84,000 packets per second. Now 88,000 packets per second. So we are seeing achieved loads beyond what the theoretical max is for this device. And that's what the throughput test is going to do, is just go along and run the test and give us the truthful answer of what was delivered downstream. So here we have downstream the theoretical max and the actual results. Now let's go down and look in the details here. So theoretical max we saw before was 759.6 megabits. The throughput that was recorded was over a gigabit. Now we know from an earlier session when we were looking at frame loss that in the downstream direction, this access point does not practice random backoff. It puts the next frame on the air as soon as the interframe spacing has reached its minimum. And so the reason this device gets higher than theoretical max is because it's not following the IEEE standard. The point here is if your customer is seeing throughput that is beyond theoretical max, this is not a good thing. It's not something for them to be happy about and thinking that they've got a better device than they thought they had. They actually have a worse device and they need to go fix this. So this is the downstream test. While we're on the throughput test here, though, I want to go back and point out how easy it would be to now run the higher client case. Let's go back and make it 20 clients downstream. And what the test will do is automatically take those the 15, 18 byte frames and lay them across all 20 clients. Now we can either make the Ethernet clients 20 as well. Let's just do that. Or we could do many to one. It really doesn't matter, right? But if we run this very same test, we don't have to change anything. We just told the application to increase the number of clients, and we'll do the Ethernet to wireless. And let's just go ahead and run that test once. We're going to see it does exactly the same thing, but now it's going to take the time to get 20 Wi-Fi clients connected, 20 Ethernet clients connected, get IP addresses for each one of them. So it's going to take a little bit longer here. We're talking about a consumer grade access point. So it takes a little bit of time. You notice here it took about 12 seconds before the first Ethernet client got its IP address back. And then it kind of goes fast from there. But there are some big gaps in here. 23,000 milliseconds. So the cards keep working and attempting the connection until finally gets an IP address on each one of the clients. Now, one of the things that you'll notice here is the first time you run a test, you may see it take the length of time that we just saw. You come back and run that same test again, and the MAC address is already known to the access point, and it will hand out the IP address sooner. So now you see it ran that first downstream, right? But now what it's doing is it is taking that intended load and spreading it across all 20 clients, right? So we have 20 Ethernet clients, all now pushing data to 20 Wi-Fi clients. So we still have the same net traffic across the access point. They're just being divided. That's just being divided across 20 clients. Now we begin to see we get a little bit of loss here, right? So we will find that the throughput decreases once we get more clients in the downstream direction. This is most likely due to the fact that less aggregation is being done on each client, because now the access point has to manage traffic to all 20 clients downstream. Okay, so now we see that the downstream throughput drops into the 734 megabit range. Now, if we wanted to analyze what really happened over the air, remember, we would stay in the same setup where we don't change anything about the ports or the clients, but we can go do a packet loss test, 15, 18 byte frames. We can choose the number of frames we want, choose the direction we want, and we'd go up here and save that hardware log. But we would decrease the test time way down to something like 1 second, let's say. And when we run that test and open up the log file, then because we have configured our Wireshark to have a client ID and a flow ID, we can now see individual aggregates being created by each one of by the AP for each one of the clients, how the WLAN sequence numbers are progressing along, and we can see the actual behavior over the air, and we can see the reason why the throughput dropped. Like I say, most likely it's going to be because the amount of aggregations that's done for any given client now has decreased, so the media is not utilized as highly as it was. So that's our first downstream throughput test, and running a throughput test with a higher number of clients.